Okay, so these are the notes for writing system of equations word problems. So writing system of equations. For step 1, we are going to identify and define the variables. Second, we're going to write the system of equations. Then what we're going to do is we're going to rewrite the system of equations in standard form, which is the ax plus by plus cz is equal to d. And last, we are going to convert that to an augmented matrix. We're going to write the augmented matrix. Okay, so let's take a look at these word problems here. First, I'm going to read through it, and then I'm going to write my variables, define them, write the equations, and then convert it to an augmented matrix. So a scholarship award was given to the student who was awarded the most points, and a different number of points are given for each first, second, and third place vote. The table shows the votes for the top 3 finishers. Find the number of points awarded for each vote. So we're looking for the number of points awarded for each vote. So variables I like to use, regardless of the situation, is usually just x, y, and z. Next, we're going to talk about what each variable means. So different point values were given, so find the number of points awarded for each vote. So for x, I'm going to run out of space. I'm going to use the pound sign, which means number. So the number of points awarded for first place. For y, it's going to be the number of points awarded for second. And for z, that's going to be the number of points awarded for third. Let's change this to... All right. So now these are easy. I like the table setup ones because they're actually pretty much drawn out for you. So here we have first place, second place, third place, and then we have the point total. So it's actually set up. This is actually going to be my x column, y column, z column. So whenever I see these, I kind of go straight to the table, and I know I'm going to add all these up, and that gives me the total. And these are actually my equations right here. Not much work to these when you have these tables set up nicely like this. So my equation is going to be, first one's going to be 23x plus 8y plus 1z is equal to 141. So I don't put the 1 because it's not necessary. 8x plus 18y plus 3z is equal to 100. And then 1x, so it's just x, plus 3y plus 5z is equal to 24. Now, these are all in standard form already. We can see their x's, y's, z's, and constants on the right side. So I can go straight to writing my augmented matrix for this. So for first one, we just use the constants, 23, 8, and 1. And then my, coefficients, 23, 8, and 1, and my constant is 141. And I put my dashed line to represent the equal bar. Remember, you can make that solid. It's up to you. From here, 8, 18, 300. And then 1, 3, 5, 24. And there is my augmented matrix. All right, let's take a look at the next one. So here is the next problem. So example 2 says 3 orders are placed at a pizza shop. 2 small pizzas, a liter of soda, and a salad cost $14. 1 small pizza, a liter of soda, and 3 salads cost $15. And 3 small pizzas, a liter of soda, and 2 salads cost $22. How much does a salad cost? Okay, so once again, I like to use x, y, and z. And it says, how much does a salad cost? So pretty much what we're doing is we are looking for the cost of each one. So for x, I like to keep in order, so the 2 small pizzas. So x is going to be the cost of a pizza. Y is going to be a liter of soda, so the cost of a liter of soda. And then we talked about the salad, so cost of a salad. All right, so these equations are nicely set up. So 2 small pizzas, 2x, a liter of soda, which is 1y, and a salad, which is z, equals $14. So we can write 2x plus y plus z equals a total of $14. And I'm gonna set up the second one the same way. 1 small pizza, a liter of soda, we're adding that together, and 3 salads is equal to $15. 3 small pizzas, so this is my third equation now, 3x, a liter of soda plus 1y, and 2 salads is equal to $22. So once again, if you look at these 3 equations, they are already all in standard form, so we can go straight to our augmented matrix. Once again, use the coefficients and constant on the right. So 2, 1, 1, 14. 1, 1, 3, 15. 3, 1, 2, 22. All right, and now we're down to our last problem here. It says, Bayside High School Orchestra performed 2 concerts to raise money for field trips. Tickets were $8 for adults and $5 for students and teachers. So $5 for students, $5 for teachers. In total, 423 people attended both concerts, and the orchestra raised $2,616. The number of teachers who came was a third of the number of students. How many of each group attended the concerts? Okay, so first we use our variables. So once again, I like x, y, and z. The definition, so it says how many. So for x, my first thing that showed up was adults. So I'm gonna say this is the number of adults who attended the concerts. Y will be the number of students that attended the concerts. And Z will be the number of teachers that attended the concert. All right, for my first equation, it says in total, 423 people attended the concerts. So that means that all of the adults, X, plus all of the students, Y, plus all of the teachers, Z, was a total of 423 people total. So that's the total. Next, we talk about money. It says the orchestra raised $2,616. Well, the way they raised that was they charged $8 for adult tickets, so 8 times all the number of adults that attended, plus $5 times every student that attended, plus $5 for every teacher that attended, and once again, they raised $2,616. Now for the last one, I'm gonna write it out here. The number of teachers, so teachers is Z, who came was a third of the number of students, so equals a third of the number of students, and the number of students is Y. So Z equals 1/3 Y. All right, so last thing we do, we're gonna rewrite this in standard form. So X plus Y plus Z is equal to 423. 8X plus 5Y plus 5Z is equal to 2,616. And then last, we have this one, Z equals 1/3 Y. We're gonna have to subtract the 1/3, and that's a positive Z. And here, there is no constant, so we're gonna set it equal to 0. And then last, we write our augmented matrix. So 1, 1, 1, 423. 8, 5, 5, 26, 16. There is no X, we put a 0. Negative 1/3, 1, and 0.